Hi, second year students. Let's see the application of integration. Integration with definite integral having upper and lower limits is also known as termed as area under the curve. Area under the curve. There are two possibilities for area under the curve. It is if it is above the x-axis, then area is positive. If area is below x-axis, then area is negative. Most people consider this lower portion as positive. It is a mistake. Look at the quantum mechanics, matter, antimatter, particle, antiparticle. If we discard negative symbol, negative sign, then quantum mechanics is 100% collapses. And quantum mechanics is a field of brilliant, wonderful modern science where everything fails, nothing survives except energy. So we have to consider positive as well as negative. Negative cannot be turned down. Negative cannot be converted into positive by simply saying that area is always positive. It has geometrical significance. It has geometrical significance. Keep negative sign intact in order to give a good view. You should give others that it is area somewhere below x-axis and above x-axis. So simply a negative symbol has significance. Don't discard it. Don't discard it. Respect it. Let's see and find out without wasting time. Exercise 3.6. We are asked, sketch the region where area is represented by the definite integral. It is known as lower limit, upper limit. This integral is known as definite integral. Without limits, it is known as indefinite. Without limit, it is known as indefinite. And we have finally plus c as a constant. In definite integral, we have each and everything definite. It is lower limit, it is upper limit. There is one respect more. Lower limit is always less than the upper limit. Lower limit is always less than or equal to upper limit. It is lesser, it is greater. So we are asked and evaluate the integral by using an appropriate formula from geometry. Appropriate formula from geometry. This look 0 to 4. It is on x-axis. Let me take f of x means value of y is x or f of x is x. Y is x. You are familiar with this. It is a straight line, a line that bisects first as well as third quadrant, or simply makes an angle of 45 degree. Makes an angle of 45 degree. It is something mystery that you are about to learn. Here it is 1. In that case, m is equal to tan theta. It is slope tan theta is equal to 1, and we are familiar when tan theta is 1, it is 45 or pi upon 4 radian. Without going into this mystery, take the limits. This is the graph of y is equal to x. This is the graph of y is equal to x. It bisects first as well as third quadrant. Or simply from this we can infer that it is slope. Coefficient of x is known as slope. If coefficient of y is 1 and x is on the right hand side, whatever is the coefficient of x, it is our slope. Or compare this equation with famous slope intercept form. Slope intercept form. Here m is 1. From m is equal to 1, utilizing the formula m is equal to tan theta 1. M in that case gradient is 1 tan theta. We have theta is equal to tan inverse of 1. So we arrive at the radius. We have angle 45 or pi upon 4 radian. So this angle is of 45, means this line bisects first quadrant as well as third quadrant, bisects in two equal parts, 45 45. Okay, making life simple, plot the limit. It is 0 to 4. It is 0 to 4. Roughly, it's our 1, 2, 3, 4. It's our 1, 2, 3, and 4. 0 to 4. And we have x. And we have x. Look at this. If we put 0, in that case, these are the limits of x. These are the limits of x. Values of x. Values of x. If we put 0, we will get, put x is equal to 0 as the limits are given. So y is 0. Put x is equal to 4. We have y is equal to also 4. So y also goes up towards 4 to 4 units. 1, 2, 3, 4. It's a rough sketch. It's a rough sketch. Making life simple. So this is our area we are interested in. This is our area we are interested in above x-axis and below this line. This is the area we are interested in. You are 100% going to 100% accurately surmise guess it is a right triangle. It is a right triangle. It is a right triangle having base 4 as well as height 4. Height 4. Base 4 x-axis. Its expansion is 4 from 0 to 4. X varies from 0 to 4 as well as y varies 0 to 4. We are interested in this portion. It is a right triangle. Its area is given by 1 over 2 base times altitude or height. We have 1 over 2, base is 4 as well as height is 4. Applying table 2 for the 8, 8 square units. 8 square units is our answer. 8 square units is our answer. Or from definite integral point of view, it is simple to integrate. 0 to 4, integrate, integration of x is x square over 2. Okay, introduce c, that's 0, that's 4. First we put upper limit minus lower limit. Upper limit in case of 4 as well as lower limit. So we are going to have 4 square over 2 plus c. We have plugged in the value of upper limit, then negative sign lower limit. 0 square 2 plus c. It will become 16. 16 divided by 4 square means 16. 4 square means 16. 16 divided by 2, it's our 8. 16 divided by 2 plus c, and here plus minus this is 0. Vanish. CC cancelled out. 16 over 2 means 8 square units. 8 square units. We are asked only geometrically find the area under the definite integral. Area under the curve. By using appropriate formula from geometry, that is 1 upon 2 base into height. A formula for area of a right triangle. Area of a right triangle. As well as we have verified by using integration and putting the limit, upper limit minus lower limit. Same is the case with question number 2. Let me erase this first. Same we have limits minus 3 to 0. Minus 3 to 0, these are the limits. It is definite integral, same x dx. Once again, it's our f of x or y is equal to x. Y is equal to x. Same line, same graph. Here we have values of x minus 3 to 0. Minus 3 to 0. That's minus 1, minus 2, minus 3. Let me draw a bigger picture. Minus 1, minus 2, minus 3. This minus 3 to 0. That's the expansion of, this is the span of x from 0 to minus 3. From 0 to minus 3. We put both values here. We will get 0 for 0 and negative 3 for negative 3. If I put 0, then y is 0. If I put x is equal to 0, y is also 0. If I put x is equal to minus 3, y is also minus 3. So y also stretches down to 3. Stretches down to 3. Stretches down to 3. Let me draw a brief one. 1, 2, and it's 3. And it's 3. What about its graph? Its graph is given by bisecting the first and the third quadrant. Bisecting the first and the third quadrant. Bisecting the first and the third quadrant. And we are interested in the graph. Same. This is our graph. This is our graph. Again, same. Again, same. It is our right triangle. It's our right triangle. Its expansion is no doubt 3, as well as its height downwards. It's also 3. It's also 3. It's also 3. Below x-axis. Below x-axis. Below x-axis. Its area is going to be 1 upon 2 base times height. That is 1 upon 2. 3 times 3. That's our 9 over 2. Respect the position. It is below x-axis. It is below x-axis. It is below x-axis. Give it a geometrical significance by introducing minus. It's negative 9 over 2 or 4.5 square units. Square units. Square units. We are familiar. Its area is 4.5 or 9 over 2. Give this minus a respect because it shows, it gives us this geometrical significance, clarifies that it is below x-axis. It is below x-axis. It is below x-axis. It is below x-axis. Respect the symbol. Respect the negative sign. Don't discard it. Don't discard it. So its area is given by 4.5 square units. Negative sign shows that it is below x-axis. It is below x-axis. It is below x-axis. Okay, cool. Moving towards question number 3. Moving question. One can verify by using integrating x square over 2 and putting upper and lower limit in the same fashion. Okay, question number 3. 3 is our limits are 0 to 2, x minus 1 times dx, f of x. This is value of y or f of x. Y or f of x means y is equal to x minus 1. How to draw the graph of a straight line? Simple. Find x-intercept and y-intercept. Plot x-intercept and y-intercept. Put x is equal to 0 means y-intercept. Put x is equal to 0, we have y is equal to minus 1. And similarly, put y is equal to 0, we get x is equal to 1 in that case. X is equal to 1. So this is our x-intercept, 1 comma 0. This is our y-intercept, 0 comma minus 1. Plot these two in a brave fashion. X is 1. Here it's 1. And y is negative 1. Here a line runs through 1 and minus 1. X is equal to 1 and y is equal to minus 1. This is our line. This is our line. And x varies from 0 to 2. And x varies from 0 to 2. This is 1. Here is 2. This is 1. This is 2. Here. How to get values of y? Really very simple. We have y is equal to x minus 1. X varies from 0 to 2. Put x is equal to 0. When we put x is equal to 0, we have y is equal to minus 1. We have y is equal to minus 1, that we have already signifies. Put x is equal to, we get y is equal to 2 minus 1, y is 1. Y is 1. Here it's 1. Here it's 1. Plot the graph that we are interested in. Okay, this line must be here. Okay, let me shrink the 2. This one, that is 1 to 2. This is the right triangle. Its dimensions are 2 minus 1 is 1. Its length is 1 as well as height is 1. Height is 1. Height is 1. Height is 1. In the same fashion, in the same token, what about this? This is also 1. Base of this right triangle 1. This is also minus 1 means we have to take its length. Its length. Look, we are interested in the area of this one, this one. Respect the geometrical significance. This is negative, this is positive. What about area of this? Let me call it A1. Let me call it A2. A2. Area of A1 is 1 upon 2 base times height. Base is 1. From 1 to 2, 1 to 2, 1 to 2, 1 to 2. 2 minus 1 means 1. Its length is 1 as well as height is 1. It will become 1 over 2. What about this? What about this? Its area of A2. It's also 1 over 2. What is its base? What is its base? 1. What is its height? It's 1. It's also 1. It's also 1. It will become 1 over 2. As it is below the line, as it is below x-axis, as it is below x-axis, as it is below x-axis, respect it, it's negative, it's negative, it's negative. So lump sum area is going to be the sum of both A1 plus A2. 1 over 2, negative 1 over 2 cancel out. 0 is our lump sum area in that case. 0 is lump sum area in that case. If we discard the symbol of this one, it is going to be 1. It is going to be 1. That it's a mistake. It's a mistake. Respect the symbol. If it is below, if your portion of the curve lies below x-axis, its area considered to be negative. above axis, its area considered to be positive, then add them simply. Add them simply. Whatever the answer is, it's your answer. Okay, cool. Moving towards question number 4. Okay, let me give you integral concept. Same question, 0 to x minus 1 dx. It's simple integration. Integrate. Integration of x is x square to integration of 1 is x. Introduce constant c and limits up 0 to 2. First put upper limit minus lower limit. Upper limit minus lower limit. Instead of x, insert 2 bracket square. I have written bracket, that is the place of upper limit. Negative sign, place of lower limit. Now 0 square over 2 plus c. Lower limit is 0. It's all 0, 0, c only left. It will become 4 over 2 minus 2 plus c. Discard, positive, negative, negative, c cancel out. 4 over 2 is 2. 2 minus 2 is 0. 0 is our correct answer. 0 is our correct answer. If you ignore negative sign, then you are going to tumble over. It is not a mathematical concept. Respect the minus. Don't discard the negative sign by saying that area is always positive. The negative sign shows that the area lies below the x-axis. Only. Simple as that. Nothing else. Not more than that, not less than that. Question number 4, simple one. There is x minus 1, there is x plus 2. Almost same. 0 to 1, x plus 1 times dx. Sorry, 0 to 2. Limits are 0 to 2. First draw the graph. Take only it is value of f of x or y is equal to x plus 1. Just utilize the x-intercept as well as y-intercept to draw the graph of a straight line. It's enough for you to draw the graph of a straight line in 2 dimensions. X and y-intercepts are far more than enough. Put x is equal to 0. You will get y is equal to 1. This is our y-intercept. Similarly, put y is equal to 0. This is our x-intercept. It is going to be x is equal to minus 1 and 0. Plot these 2 points. Plot these 2 points. It will give you a good idea about a straight line. X is minus 1 and y is 1. Our line must run through both these points. Okay, this is our overall graph. Now we have to shrink or cut off the graph from 0 to 2. We are interested only 0 to 2. That's our 0, 1, that's our 2. That's our 1, that's our 2. Extend it. Now we are interested in the area from where 0 to 2. It's 0 means this portion and this one. We are interested in this. We are interested in that region. We need the area of this 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 region. From plane geometry, you are familiar. It is our trapezium. It is our trapezium. These 2 sides are parallel. These 2 sides are parallel and these 2 sides are not parallel. So area of trapezium is going given by 1 upon 2 sum of parallel sides. Sum of parallel sides times height. What is height in that case? Let me demarcate y and x. If I put 0 to 2, our equation is y is equal to x plus 1, put x is equal to 0, then I am going to get y is equal to 1. This is my y is equal to 1. And if I put x is equal to 2, then I am going to get 2 plus 1, y is equal to 3. Y is equal to 3. So this is 1, 2. So it is equal to 3. Here y is equal to 3. It is y is equal to 3. So this height is going to be 3. This height is going to be 3. This is 1. This is 1. These are parallel sides. 1 and 3. These are our parallel sides. Parallel side. Having length 1 as well as 3. Having length 1 as well as 3. What about height? Our height is this one, 0 to 2, 0 to 2, 0 to 2. Sum of parallel side times height. Height is going to be this one. Height is going to be this one. 1 plus 3. Parallel sides. This is parallel as well as y-axis are parallel. And x we have considered as height, as necessity is mother of invention. So our height is 2. 2 to cancel out. Cancel out 4 square units is the area in that case. 4 square units. 4 square units. 4 square units. Or one can verify by simply integrating. In that case, we are asked to give a geometrical formula, geometrical logic to arrive at the area result. We are also verifying by integrating. Let's see and find out its simple integration and telling the answer. Its simple integration 0 to 2 x plus 1 times dx. Integration of x is x square over 2 plus 1 times x. Let's see here over to 2. Upper limit minus lower limit as usual. Upper limit minus lower limit. What is the upper limit? 2 bracket square over 2 plus bracket empty bracket c. In empty bracket I have to accommodate upper limit, negative sign, and then lower limit. O square over 2 empty bracket accommodate 0 in that case. It's 0. What remains c? It's 4 over 2 plus 2 plus c minus plus minus c. C cancelled out. 4 over 2 is 2. 2 plus 2 is my 4. 4 square units. 4 square units. Adopt any trajectory. Take any path. Tread it. If you have concept, then you are arrived at same result. Otherwise, you are roaming here and there, not arriving at the result. Okay, final question of first one. Question number 5. Upper limits are minus 3 to 3, 2 dx. 2 dx. Now I have y is equal to. Let me plot the graph of y is equal to. Y is equal to 2. Here 1, here 2. If I extend this one, it's a line parallel to x-axis. It's a line parallel to x-axis. And the range of x is from minus 3 to 3. Minus 3 to 3. Minus 1, minus 2, minus 3. Okay, yeah. And positive 1, 2, and 3. This is our shape. Our height is 2. Definitely it's 2. And our stretch of x is 6. The stretch of x is 6. It's simple rectangle. Its area is given by length times width or breadth. It's 6 times 2. 12 is our answer. Or one can verify by by integrating minus 3 to 3, 2 dx. 2 is the constant right outside. We are familiar. 1 is the integration of 1 is x. Integration of 1 is x with respect to x. 2 times x. Upper limit minus lower limit. Simply we are going to have 2 times 3 minus 3. I have discarded c already. 2, 3 plus 3. 3 plus 3 is 6. 2 times 6 again. 12 is my same answer. 12 is my same answer. This is a geometrical view of area under the curve or application of integration. Mostly, our regular figure has formula for their areas. Whenever they have irregular shape, then our definite integral is going to assist us, help us to find its area. Question number 2. It's a piecewise function. It states that f of x is equal to x if x is less than or equal to 1 and f of x is equal to 3 if x is greater than 1. Keeping this given fact in mind, f of x is a piecewise function. When value of x is less than or equal to 1, then we have to pick x as a function. If value of x is greater than 1, then we have to pick f of x is equal to 3. F of x is equal to 3 as a constant function. If x is greater than 1, then we have to integrate. Let's see question number 1. Our limit runs from 0 to 1. F of x dx. What are the values? 0 to 1. Less than or equal to 1, we have to take this. This interval 0 to 1. Satisfied by this interval, it is greater than 1. We have our limit 0 to 1. That falls in that interval. That lies in that interval. So we have to take the corresponding function. F of x is going to be r x. Simply integration of x is x square over 2 plus c, upper lower limit, whatever the result, just write 1 square over 2 plus c minus 0 square over 2 plus c. C cancelled out. I have only left with 1 over 2. I have left with only 1 over 2. This is area of 0 to 1 f of x dx when piecewise function is this one. Okay, what about 2? It has limit from minus 1 to 1. Minus 1, respect the given interval. Respect the given interval. We have to break the given limits as either they fall on this or they fall in this. Either in this or in this, not in both, not overlapping. We have to separate according to this given partition. The given partition or main partition or wall lies at x is equal to 1. At x is equal to 1. Second question is minus 1 to 1 f of x dx. Look, it is the mixture of both. Separate them. We have less than 1, we have greater than 1. We have less than 1, we have greater than 1. So we can write this definite integral as minus 1 to 0 f of x dx. Then from 0 to 1 f of x dx, or both of them from minus 1 to 1, they collectively fall in this interval. They are falling in this interval. One limit is enough for us. Either write in that fashion or one limit is enough for us. Let me solve in both fashions. Minus 1 to 1 lies in that interval. Minus 1 to 1 lies in that interval. We have to take this value. So minus 1 to 1 x dx. Integrate x square over 2 plus c, upper limit minus lower limit, or upper limit is 1 square over 2 plus c minus, our lower limit is minus 1 square over 2 plus c. Owing to this even power minus turn positive, it will become 1 over 2 plus c. Another bracket negative times negative 1 over 2 plus c. Both brackets are identical, cancelled out. So 0 is our area in that case. 0 square units. 0 square units is our area in that case. If we split this from minus 1 to 0 and 0 to 1, still we get the same answer. But minus 1 to 1 completely falls on the left side of this one, left side of the one. So we have taken less than or equal to interval. Our value of x falls in this. So we have taken the corresponding function f of x is equal to x and we have integrated. So part number 3, it is from 1 to 4. It falls on the right. Third one, f of x is equal to, let me write question. 1 to 4 f of x dx. 1 to 4, as 1 to 4 greater than 1. This values of x lies in this interval. We have to take corresponding function, that's 3. 1 to 4 3 dx. 3 is a constant, right outside. 1 to 4 dx. Integration of 1 is x plus c, putting upper and lower limit, making life simple. 3 times x is 4 plus c minus 1 plus c. Multiplying minus, I have 3 times 4 plus c minus 1 minus c cancelled out. 4 minus 1 is 3. 4 minus 1 is 3 3 is 9. 3 3 is 9. Or one can put limit in that fashion. 3 times x plus c, and whatever the case is, we arrive at the same result. 1 to 4 lies on the right hand side of this interval. Right on the partition, x is greater than 1. From 1 to 4, this is the interval where x is greater than or equal to 4. X is greater than 1. So we have chosen the corresponding function f of x is equal to 3 and we have integrated this one as well. Question number 4 now it is. Final part. Minus 1 to 2 is our limit. Sorry, I have erased the function. Let me write again. F of x is x if x is less than or equal to 1 is equal to 3 if x is greater than 1. Making life simple, take in the fourth and final part, minus 1 to 2 f of x dx. Bingo! In this interval lies on the left as well as the right, as well as on the right. We have to separate towards left, towards right. Towards left is going to be minus 1 to 1. Minus 1 to 1. This lies on the left hand side and greater than 1 lies on the upper side. So it is minus 1 to 1 f of x dx plus 1 to 2 f of x dx. You can broken down this minus 1 to 2 in as many parts as you like, as many parts as you like. For our convenience, we have x is less than 1 and x is greater than, x is less than 1 and x is greater than 1. Minus 1 to 1, then greater than 1 to 2, then greater than 1 to 2, because our partition lies at x is equal to 1. Right side of the left, right on the right hand side of x means x is greater than 1 according to this. On the left side of 1 it means x is less than 1. According to this suitability, I have broken down minus 1 to 2 in minus 1 to 1 falling in this part, from 1 to positive 2 falling in this part. For this mine value is x, for this mine value is 3. So minus 1 to 1 x dx plus for 1 to 2 I have 3 dx. Integrating, it has limits from minus 1 to 1, it has limit from 1 to 2. Integrate x square over 2 plus c plus 3x plus c. As c has been cancelled out, putting upper and lower limit separate, minus 1 to 1, 1 to 2, 1 to 2. Generating the space for myself. Okay, I have put upper limit, that is 1 square over 2 plus c minus lower limit minus 1 square over 2 plus c. That is for this part. What about this part? Let's see and find out. Plus upper limit 3 times 2 plus c minus 3 times 1 plus c. Upper limit minus lower limit. This is mine upper limit. This is mine lower limit. 2 and 1. Making life simple and calculating. This is going to be 1 over 2 plus c. It is a, owing to this even power it will become minus. Owing to this minus it will become minus. It is also minus. Both are cancelled out in that case. What about this? Plus 3 to the 6 plus c minus 3 minus c. C cancelled out. 6 minus 3. 3 is our going to be final answer in that case. 3 is going to be our final answer in that case. Okay. Now the rest. It is a graph reading according to area under the curve. We have given each and everything. Is it good? Angle is good? Good to go? Okay, here everything is given. From A to B, area is 2, it is mentioned explicitly given. From B to C, area is given to us, that's 3. Area from C to D, it is given to us 3 to 5. Everything is given. Just read these limits and put the values. Read these limits, put the value. However, I am not agree with this positive 3. I am not agree with this positive 3. It must be minus 3. It must be minus 3. I am giving them respect, taking this one as positive. Otherwise, below x-axis, this area must be negative. This area must be negative. This area must be negative. As they have given us positive, I am respecting them and solving according to the given condition. Mine first is A to B f of x dx. It is given to me. The area from A to B is 2. That's A1. It's mine A1. That's equal to mine answer. Nothing else. Nothing else. Number 1. Number 2. That is from B to C. That is from B to C. F of x. It is to be A2. A2. That is, according to me, it must be negative. According to me, it must be negative. Whatever they have given, I am respecting them. I am writing positive 3. It's our answer. What about third part? That is C to D. C to D. Sorry. C to D f of x dx, that is A3. That is A3, it is given to us. That is 3 point. For just reading the graph, nothing else. What about A to C? Fourth, A to C f of x dx. Look, A to C, A to C, A to C, A to C. I can split it from A to B, then B to C. I can split it A to B, then B to C, taking the corresponding intervals. Taking the corresponding intervals in that case. A to C can be written as A to B f of x dx plus from B to C f of x dx. Plug in the corresponding values from A to B. This is mine A1. From B to C, that's mine 3, A2. So value of A1 is 2, value of A3 is 3, 2 plus 3, 5 is answer in that case. 5 is answer in that case. A to C, I have done fourth one. Then 5 and 6 finally. Let me erase this first and say bye bye to these. 5 and 6. 5 1 is from B to D. From B to D. From B to D. We can split from B to C. From B to C, then C to D. Question number 5. It runs as, our limit runs as B to D. B to D f of x dx. According to the given interval, it can be broken down from B to C, then C to D. It's equal to B to C f of x dx plus C to D f of x dx. B to C, B to C. What is B to C? It's A2. From C to D, it's A3. Fitting the corresponding values, A2 is 3 and A3 is 3.5. It's our 6.5 square units. Finally, we have from A to D. A to D, it can be broken down from A to B, then from B to C, then from C to D, and putting the corresponding values. 6 1, A to D, sorry, A to D, f of x dx. According to the given partition, first interval is A to B, second B to C, then C to D. Okay, A to B is first interval f of x dx plus B to C f of x dx, that's second interval. C to D f of x dx, it's our third interval. Value from A to B, it's our A1, it's our A2, it's our A3. Let me write, it's A1 plus A2 plus A3. Value of A2 is 2, value of A3 is 3, value of A3 is 3.5. How much? 5, 8, 8.5. 8.5 square units. 8.5 square units. It's my tiny effort, you guys, to explain to you area under the curve. Area under the curve. Respect that thing. Below x-axis, area must be negative. Area must be negative, and we cannot discard that minus sign. However, I have given them respect. The book, whatever they have mentioned, I have solved according to them. But keep in mind, below x-axis area is negative, and we have to consider that negative. Quantum mechanics don't discard negative values, because if we discard matter, antimatter, particle, antimatter, energy and negative energy, matter, dark matter, everything collapses. We have to respect this negative sign. We have to respect this negative signs. It shows us geometrical significance. Geometrical significance. The first question that we have done, in that case, whose area is 0, this would have been collapses. Look, that is the answer of this one. In that case, we have two intervals, two triangles. In that fashion, I think we have done so. In that fashion, okay, they are same. They are same. If we are taking this one positive, then its answer is not 0. Then its answer is not 0. Then our definite integral collapses. We have to respect whatever is given to us. We cannot discard negative sign in that case if our function is continuous, containing more than one part. However, if we have given independent this one, we can discard negative sign, but having negative sign shows us that it is the area below x-axis. It must be acceptable, it must be respected. It's my tiny effort you guys to explain to you area under the curve. It's all by itself. Next.